Hey, have you ever been intimidated by the so-called Big O notation before? Don't worry, because in this video I'm going to demystify this concept for you so that you can confidently use and speak about it in the future without any hesitation. But before we dive in, let me introduce you to my Learning Data Structures and Algorithms course. It's completely free and it will stay that way forever. So don't wait any rule now to learn more. You will find a link to the course in the video description below. To understand Big O notation and what is used for, we should first start by defining what's an algorithm. Generally speaking, in easy words, an algorithm is just a solution to a specific problem. When your mom makes the most delicious cake ever, that's an algorithm. When you try to find a shortcut to drive to work because you're late, that's also an algorithm. And when I make this video to explain Big O notation for you, that's another algorithm too. So basically, algorithms are everywhere. Now let's put this broad definition of an algorithm in the context of computer science and try to define it again. An algorithm is just a set of well-defined instructions or rules written in a natural language that describe a step-by-step process to solve a specific problem or perform a specific task. Usually we use an artificial language, aka a programming language, to translate an algorithm to something that a machine can execute. Now let's move on to the next question, which is, what's a good algorithm? How can we tell if an algorithm is good or not? To answer this question, let's see the following scenario. Assuming that on day one, you and your friend were told to write different solution in your favorite programming language to turn off lights on a particular given house. On day two, we tested your solutions on my house, so they both were on time and did well. On day three, we wanted to do something a little bit crazy to test how well your solution performed when we scale the problem. So we tested them to turn off lights in every house in the city. Your solution did well and completed the task in 1 minute time. However, your friend's solution took 10 minutes to do the job. So we can conclude that your solution is a good one and is better than your friend's solution. No, not necessarily, because when we tested your friend's solution on your machine, it did better than yours. So the point I'm trying to make here is that we can't practically rely on testing solutions on every machine and with different ranges of inputs to make an assumption about its performance. So we need something else. We need a theoretical method or theoretical approach to tell how performant a solution is. Here the Big O notations come to the rescue. So what's Big O notation? It's basically a mathematical method we use to measure the complexity of an algorithm. Therefore, we can tell how well it scales in terms of the time or the space it needs to solve a particular problem with a larger number of inputs. Big O notation is usually denoted by the capital letter O. It represents the upper bound of an algorithm's time or space complexity as shown in the figure. We can see that the time or space complexity changes accordingly to the input size denoted by the letter N. The more the curve goes up, the more the complexity increases. So you should always strive and try your best to find solutions that fall into the excellent, good or fair regions. In part 2 of this tutorial, we'll highlight the different complexity cases shown in this graph. And we'll also learn how to calculate time and space complexity with some examples. This is it for this video. I hope that you've learned something new today. Don't forget to comment, like, share and subscribe to my channel. Thanks for watching and see you soon.